looking down into a primordial deep sea. It's dark except for the glowing warm light coming off of volcanic vents rising up from the seafloor. These were some of the earliest sources of chemical energy on Earth. And right in front of them, we see our first example of life: translucent, simple prokaryotic cells. These are very likely similar to the modern-day descendants of those ancient bacteria called Caetinobacteria, which are still found living near hydrothermal vents today. Also, in the bottom right, we can see the first microscopic fossils known as stromatolites, layered structures formed by the growth and reproduction of photosynthetic bacteria. Above them, the ocean itself looks murky, reddish in color, full of dissolved iron and other minerals that absorb and scatter the sunlight. This would have been the state of the ocean before the oxygen produced by photosynthesis began to accumulate in the atmosphere and before the Earth's surface had fully cooled. As we move to the right, we enter the Proterozoic Eon, which begins around 2.5 billion years ago and ends around 540 million years ago. In the bottom left, the shallow seas are teeming with diverse life, mostly single-celled eukaryotes, organisms with a nucleus, and other membrane-bound organelles. The first complex multicellular organisms would evolve during this time, and by the end we'd see the first animals like the frond-like jellyfish and comb jellies known as the cnidarians, which would eventually give rise to all modern-day animals. We also see the first hard-bodied organisms, which are able to grow large, thanks to the protection provided by shells and skeletons. These include creatures like the Archaeocyathra, a type of sponge-like organism, found in the fossil record only from this time period, the Eocene. A group of enigmatic organisms with a range of bizarre body plans, many of which resemble the fronds of large seaweeds. While their relationships to other organisms are debated, they represent some of the earliest large macroscopic animals ever to live. As we continue to the right, we reach the Paleozoic era. By this time, life has exploded in diversity and number. We are looking down on a shallow, sunlit sea that is crowded with a dense mix of swimming creatures and crawling things along the seabed. This is a depiction of the Cambrian explosion, a dramatic increase in the diversity of life that occurred around 500 million years ago. At this time, most of the major animal phyla that exist today first appeared in the fossil record. Among them is the phylum Arthropoda, which includes the ancestors of today's insects, spiders, crustaceans, and myriapods. Also present are echinoderms, including the ancestors of starfish, sea urchins, and sea cucumbers. But perhaps the most impressive are the chordates, the phylum to which all vertebrates belong. In this mural, we can see a predatory Anomalocaris, one of the largest known predators of the time. Its enormous grasping appendages and toothy mouth allowed it to capture prey like the five-eyed Opabenia, a strange fish-like creature whose 5 eyes were arranged in a ring around its head. Also swimming past are trilobites, some of the most successful and long-living of all arthropods. Their 3-part segmented bodies and tough exoskeletons allowed them to thrive in virtually all environments. They dominated the oceans for over 200 million years. In the bottom right, we see a small trilobite resting on the seafloor next to a seagrass meadow made up of ancient relatives of today's vascular plants. These would be among the first plants to colonize land during the later stages of the Ordovician period, when the first bryozoans and brachiopods also made their appearance. The rest of the period would see the first major mass extinction triggered by a sudden increase in volcanic activity, which caused dramatic climate change and ocean acidification. This cleared the way for new groups of organisms to diversify during the Silurian period, such as jawed fish like the placoderms, bony fish with protective armor-like skeletons. By the end of the period, life had once again recovered and began its conquest of land driven by the first tetrapods, fitted vertebrates, who evolved from lobe-finned fish like Tiktaalik, an ancient fish that used its fleshy fins to crawl up onto the bank. Meanwhile, in the water below, smaller fish darted in and out of the seagrass meadow, feeding on algae and plankton. On the land, the first plants grew close to the shore, primitive, mossy, leafless plants like Cookstonia, which absorbed water and nutrients directly through their stems. As we move into the Devonian period, often referred to as the Age of Fishes, the seas are still dominated by a great diversity of fish, including some of the earliest sharks. Meanwhile, on land, the first forests begin to emerge composed of the first vascular plants with true roots, stems, and leaves. The Devonian would see the rise of the first terrestrial vertebrates, the tetrapods, who evolved from fleshy-finned, lobe-finned fishes like Tiktaalik. The oldest tetrapods were small, lizard-like creatures that spent much of their time in the water, but periodically came ashore to feed on insects and other invertebrates. This was just the beginning of the conquest of land. However, as the period progressed, more diverse tetrapods evolved, giving rise to the first amphibians like Ichthyostiga, large salamander-like creatures adapted for life both in and out of water. Moving into the Carboniferous period, we see giant tree-like plants with large leaves form the first extensive forests. A variety of early reptiles also appear, but it is the amphibians that dominate the landscape. Swamps became widespread during this time, and they would ultimately give rise to the coal deposits that are mined today. However, by the end of the period, the first amniotes had appeared. Early vertebrates whose embryos could develop on land thanks to the protective fluid-filled sac called the amnion. This adaptation would allow tetrapods to fully conquer land and eventually give rise to the first mammals and eventually us. By the end of the following Permian period, the first mass extinction had struck, a catastrophic event that wiped out nearly 90% of all species, known as the Great Dying. Its cause is uncertain, but it may have been triggered by massive volcanic eruptions in what is now Siberia. The fires and steam created a haze that blocked sunlight, altering the climate and causing ocean acidification. Whatever the cause, the effects were global, eliminating entire ecosystems and creating the largest gap in the fossil record of any mass extinction. And we are now in the Mesozoic era, the so-called Age of Reptiles. After the mass extinction at the end of the Permian, it would take millions of years for life to recover. But by the Triassic period, some 250 million years ago, new groups of organisms were thriving, including the first archosaurs, a group that would eventually split into two lineages, the crocodiles and the dinosaurs. The dinosaurs, which first appeared during the Triassic, were a diverse group of reptiles that lived during the Mesozoic. But it wasn't until the Jurassic period that they truly came into their own. The sweeping landscapes of the Jurassic period are dominated by giant plants like ferns and cycads. In the midground, a herd of Brachiosaurus feeds on the tall trees, their small heads high up, browsing on the succulent leaves. In the foreground, an Allosaurus stalks a smaller plant-eating dinosaur, its head lowered, preparing to strike. But it is the Triassic-Jurassic extinction event which eliminated many of the dominant groups of organisms, including the last of the large non-avian dinosaurs, clearing the way for the rise of the flowering plants, birds, and mammals during the Cretaceous period. However, the Cretaceous would see the diversification of the angiosperms, the first flowering plants. At this time, flowering plants rapidly diversified and spread across the globe, becoming the dominant terrestrial plants that we know today. During the late Cretaceous, a massive asteroid entered the Earth's atmosphere and collided with a planet. This event, known as the KPG extinction event, marked the end of an era. It brought to an end the reign of the dinosaurs and eliminated roughly 75% of all species on Earth, including many groups of marine organisms and a multitude of terrestrial animals and plants. But this catastrophe also created the conditions for the rise of mammals in the Cenozoic era. The following Paleogene and Neogene periods would see the adaptive radiation of mammals into the wide range of ecological niches left vacant by the dinosaurs. This included small, shrew-like mammals, large grazing mammals, and carnivorous mammals like wolves. By the end of the Neogene, the first grasslands had begun to appear, dominated by grasses and other non-woody plants. This would become the dominant terrestrial biome during the Quaternary, the most recent period of the Cenozoic, which includes the current Holocene epoch. During the Pleistocene epoch, commonly known as the Ice Age, the Northern Hemisphere experienced several cycles of glacial expansion and retreat, resulting in a colder, drier climate. This is depicted in the mural as a vast grassy steppe with large herds of grazing mammals like bison, horses, and deer. The landscape is also populated by iconic megafauna like woolly mammoths, giant ground sloths, and saber-toothed cats, creatures that unfortunately went extinct during the most recent mass extinction event, largely driven by human activity. Finally, on the far right of the mural, we see a small group of early hominids, specifically Homo habilis, standing on a savanna, crafting older one-stone tools. In the background, more advanced Homo sapiens can be seen looking towards the horizon, symbolizing the dawn of modern humans and the beginning of our journey to populate the globe. Overall, this mural captures the essence of life's history, highlighting the incredible diversity and resilience of life on Earth over billions of years. It shows the major transitions in life, from the earliest single-celled organisms to the complex ecosystems of today, emphasizing the interconnectedness of all living things. Now, we've got to get to work on part 2. Let me know what you think in the comments below, and I'll catch you in the next one.